Hello everyone and welcome back. In a recent video, we went over if statements in Python with several examples. Now in this video, I want to go over loops in Python with several examples of both for loops and while loops. So if you've been following along, I'm in a directory called Python Basics Fun. There's one Python file main.py where I've been taking some notes and writing some code for demos. First thing I'm going to do is comment out all of the code related to getting input from the user to play our simple guessing game, just because I don't want to have to enter that in every time we're going to test our loop code for this video. So I'm going to select it and hit Command / on Mac, or if you're on Windows, Control / just to comment it all out. So now I can start a section on loops, and if I run my code, there's nothing prompting me to enter in any values, so it'll be really fast to see immediate output from our loops. So let's get started with some notes on loops. So we use a loop to repeat statements. In Python, we have for loops and we have while loops. If you're coming from another programming language such as C++ or Java, you might also be familiar with do-while loops. We do not have a do-while loop in Python. Let's get started right away with for loops because they are really handy and we use them all the time. While loops are handy too, but just not used as often as for loops because of how generalizable the for loop structure is. So what is the for loop structure? The syntax for a for loop is for item in sequence, enter, and then tab to have the body of the for loop. And the body of your for loop is essentially one or more statements that you want repeated. Also, typically, but not always, you do something with item. So let's see some examples of this because there are lots of sequences that you can work with in Python, and those sequences are supported with iteration with for loops. So let's start with lists. Lists are sequences. So a list is a sequence of elements. So let's say I declare a list called my list. We use brackets to denote a list, and then inside the brackets we can have a comma separated list of values. So let's just do a simple list of 5 integers. 1, 2, 3, 4, 5. So what I can do is I can write a for loop for item in my list, where each iteration of the for loop, item will take on the value of an item or an element in my list. So the first iteration of the for loop, item will be 1. The next iteration of the for loop, it'll be 2. The next iteration will be 3. The next iteration will be 4. The next iteration will be 5. And then the for loop will stop executing, and execution will continue with the next executable line of code outside of the for loop and its body. So let's say as part of our body of our for loop, we want to do something with the item. So let's just print it out. Make my output a little bit bigger down here. So here's the output from our for loop. The for loop runs 5 times because there are 5 elements, aka items, in our list. Like I said earlier, each iteration of the for loop, item will take on one value in my list, and it'll take on values in the same order that my list stores the values, which is 1, 2, 3, 4, 5. So the for loop takes care of all of the initialization and assignment of our loop control variable item as it stores values iterating through my list. Let's see an example now of another sequence that can be used with a for loop, and that is a string. Let's say I want to iterate over each character in the simple string hello. I will print out the character. So the first iteration of the loop, character stores H. The next iteration, it stores E. The next iteration, it stores L. The next iteration, it stores L. And the next iteration, the final iteration, it stores O. So here's the output from my for loop, printing all the characters in hello, each on their own line. Now, I want to note here that on line 162 and line 165, I'm using a different loop control variable name. So on 162, I've named my loop control variable item. On 165, I've named my loop control variable character. This is just programmer preference. I could have, instead of naming, say, my loop control variable on 165 character, I could have used hello. And it would have ran just the same. So just keep in mind that what we declare here is a variable, and it has to adhere to all the standard naming variable requirements of Python, but it's just a variable that you get to declare. Now let's see how we can generate our own sequences using a built-in function called range. There are a few common uses of range. One includes passing in a single integer argument, which I'll call stop. So when you call the function range, passing in a value such as, say, 5 for stop, then what you get is essentially a sequence generated that runs from 0 inclusive to stop exclusive. So hopefully you've seen this interval notation before. If you haven't, no worries, I'll explain it briefly. The hard bracket means inclusive, so the sequence starts at 0 inclusive, goes up to 1, 2, 3, 4, 5 exclusive. So 5 actually is not included, which means the last value in the interval that is included would be 1 before, which is 4. Let's see an example of this. For I in range, and note that I again is a loop control variable, I'm choosing that name. And let's do for I in range 9. What this is going to do is generate a sequence, 0 inclusive to 8 inclusive, or said another way, 9 exclusive. I will take on one value one at a time in this range. So let's print out I, and just because we're going to see quite a few lines of output here, let's override our default new line character that print puts at the end of our string to be a space, and then I'll put a print outside of the for loop to get that new line character back so that the next time we call a print statement, it'll be on its own line in our console output. So here's the output of the for loop. It's going to run 9 times, 0, 1, 2, 3, 4, 5, 6, 7, 8. Notice that in addition to our for loop always starting at 0, our numbers always go up by 1. So let's see some more advanced uses of the range function, specifically how we can change that default behavior of starting at 0 and that default behavior of incrementing by 1. So there's also range where we specify a start and a stop. So for example, we could do range, say, 1 to 5, and what this would do is generate a range inclusive of start, still exclusive of stop, which for the example I gave here would be 1 inclusive up to 5 exclusive, so 1, 2, 3, 4. Let's see an example. I'm just going to copy lines 169 to 171, and let's say we want to start at 4 instead of starting at 0. So we should get the numbers 4, 5, 6, 7, 8. And there we do. So we're able to customize our range a little bit more by providing another integer argument, which is the starting value. And remember, the starting value is inclusive and the stopping value is exclusive. Now let's do one more example. Start, stop, step. So for example, let's say we want to start at 1, end at 5 exclusive, and go up by 2. So this would still be start inclusive, stop exclusive, incrementing by step. So for example, this would be 1 plus 2 is 3, plus 2 would be 5, but 5 is exclusive, so this would just give us 1 and 3. Let's see an example. Let's do 4 to 9 going up by 2. So this would be the same interval as before. incrementing by 2. So we get 4, 6, 8. For fun, we could try our 1 and our 5 here, and we see 1 and 3. So working with for loops takes a bit of practice because obviously here are 3 different ways to call the range function to generate a sequence, and what kind of sequence we need generated is usually pretty specific to the problem that we're trying to solve. So let me give you 2 problems to try and solve. The first one is try to produce the same output as our last for loop, which was 4 space 6 space 8 space, but reversed. So that would be 8 space 6 space 4 space. Try that out. Once you've written the for loop for task 1, try task 2, which is write a for loop to print out the first 20 even numbers, all on one line, separated by a comma and a space. So for example, this would be 2, 4, 6, all the way up to 40. The tricky part about this last one is we don't want a comma and a space after our last element, which is 40. So go ahead and pause the video and try this out, and then I'll go through it. So for task 1, I'm simply going to take our previous for loop and paste it. And what I want to do is adjust my start and my stop and my step. So I want to start now at 8, my largest number. I want to go down by -2, so I go 8, 6, 4. I do not want to include 2, so I want to make sure that 2 is my stopping value, which is exclusive. There I get 8, 6, 4. I also could put 3 in here and I would get the same output. Now for task 2, I'll paste our for loop again here, just so that we have something to get us started. The start of our sequence we want is 2, so I'm going to specify our inclusive starting value to be 2. Our last inclusive stopping value is 40, so I'll put 42 here because remember our stop value is exclusive, going up by 2. And then I want to separate all of the elements by a comma and a space. So I run this and I get the correct numbers. They're all separated by a comma and a space, but as I alluded to earlier, we have this extra comma space after the 40 that shouldn't be there. Now, there are a few ways to solve this problem. I'm going to solve this problem one particular way so that I can show you something interesting about for loops in Python. I'm going to stop my for loop one iteration early. So now I have my last comma and space, but I'm missing my 40, my last element that should be printed at the sequence. What I'll do is I'll actually just print I plus 2 outside of my for loop to get my last element. Now what's really cool about this is this I variable was declared inside of the for loop, but I still have access to it outside of the for loop. Even if I were to say change this to a variable I haven't used in my program before, like j, this still works. In some programming languages, if you declare an integer variable as part of, say, a for loop, like for int I get 0, I less than 5, I plus plus, something like this from the C family of languages, that variable is declared inside of the for loop, therefore it only has scope inside of the for loop, and you wouldn't be able to use it outside of the for loop like we're doing here. So this is a particular way I want to show you so you could see that you can still use your loop control variable outside of the loop, particularly if you wanted to use or check its last value. All right, so hopefully those 2 tasks help solidify how to use for loops in Python. What I thought we'd do next is move on to the while loop structure and see a few examples of while loops. So a while loop in Python has the following format. While some condition is true, colon, enter, space, right? So indenting to form the body. We have our body, which is the statements to be repeated. And then something about while loops that we don't have to do with for loops is, unless we want an infinite loop, which most times we don't, we want to have some kind of progress towards the condition being false. Okay, recall that the while loop is going to continue while some condition is true. So as part of our while loop body, we probably want to get closer and closer to that condition eventually being false so that we can break out of this while loop and continue on with whatever our next executable line of code outside of our while loop is. Now, as our first example of a while loop, let's rewrite our solution to task 2 that used a for loop to use a while loop instead. Let's introduce a new loop control variable. Let's use k. We haven't used k yet. So I'm going to initialize k to 2, and while k is less than 40, I am going to print out k. Now here's where I need progress towards my Boolean condition being false. If k starts at 2 and I only stop once k is greater than or equal to 40, then I need to increment k so that each iteration of the while loop, it gets closer and closer and closer to 40. So I'll do k plus a sign 2. Let's see what we have so far. Okay, I have everything except for the 40 on the end. So we know the only way to get to line 203 is for k to be greater than or equal to 40. So I'm going to print out k, and I see my last element here, 40. So lines 191 to 193 and lines 199 to 203 solve the exact same problem, printing the first 20 even numbers all on one line separated by a comma and a space, but using two different looping structures. So just remember, when programming, there's almost always multiple ways to solve one problem. Sometimes the solutions are different in that one's more efficient or one's more memory optimal, but sometimes one is just preferred by the programmer. So if you like for loops, you might tend to solve problems like this using for loops, or if you like while loops, you might tend to solve problems like this using while loops. So just keep in mind that you can often use a for loop or a while loop to solve the same problem, and which one you use is generally up to you. Which one do you prefer? Which one are you trying to get more practice with? All right, let's do another example of a while loop. And this example of a while loop is going to introduce us to what's known as the break statement or the break keyword. So quick notes here. You can get an early exit from a loop using the break keyword. Let's say I create an infinite loop while true. Capital T true and capital F false, these are keywords in Python. They show up in a different color in your editor because they have special meaning. We wouldn't want to try and declare a variable called capital T true or capital F false because they're keyword. They're reserved for representing a Boolean true or a Boolean false in Python. So if I say while true, I've essentially made an infinite loop. Okay, I have no way in line 206 for my condition to be false, right? It's always true. So how can I get out of this while loop? I can get out of this while loop using break. So let's say we're going to prompt the user for some input. I'll say enter a word and then stop to exit. So I'm always just going to keep reading in strings from the user. No matter what they type, I'm going to read them in, read them in, read them in. I'm going to be stuck in this loop forever. Except if the user ever enters in the string stop, which I can test for using a conditional, then I'm going to break out of this loop. When I break out of the loop, this will bring us to the next executable line of code outside of the while loop, and I'll just put a little indicator about that line on line 210 by having a print statement that will simply display here so that we know we broke out of the loop and we executed line 210. So let's try it. It says enter a word, stop to exit. So I'll do hello, goodbye, here, there, garbage. It doesn't matter what I enter in. Okay, I'm stuck in this loop until I enter in stop, in which case my condition on line 208 will be true, and we will break out of the loop. Proof here that we're outside of the loop because we see here from line 210. So just keep in mind that there is a break keyword in Python, and you might want to use it to break out of a loop. Some folks consider using break statements to be bad practice because they give you alternative ways to get out of a loop besides the traditional way, which is when your Boolean condition evaluates to false. So keep that in mind, and you'll develop your own preferences for using break or not using break. The last thing I'm going to say here as part of our video on loops is just like with conditionals, you can nest loops. Just be sure to watch your indentation. That's where nesting anything can get really tricky. Well, we covered a lot in the video, for loops and while loops with several examples. We learned about the break keyword. That's it. Thanks for watching, and consider subscribing to my channel to learn more about Python.